lab, so the SD lab leans heavily on some examples that come with the core, with the chip kit core. And when I wrote the lab, the core was kind of, the core examples weren't that great. And since I wrote the lab, I actually fixed the core examples. I submitted them back to the project, and they were accepted, and they're in there, right? So my changes are part of the core library. The problem is the lab refers to the prefixed libraries, and so there's some confusing things in it, and I'm going to try to point those out. What the changes I made actually make it easier. Fiduciary responsibility, that's why I mentioned. It says SD cards can be addressed using at least 3 different communications protocols. And the way we use it on our board, it uses SPI. There's a 4-bit communication mode that's a lot faster, but that, again, is patented by Microchip. And if you look at some examples, the micro SD, there's a mini SD, and the regular SD. All of them have similar pinouts, and they all communicate using SPI, or that you can use SPI with all of them. This SD, mini SD, micro SD. Okay, on the Fubarino, this is the micro SD connector, and you can see there's a chip select. There's a chip select, data in, VDD, which is 3.3 volts. The clock. There's ground and data out. So this is just SPI, right? Chip select, data in, data out, clock, and so those are our SPI signals. And then the 3 volts and ground power the chip. There's a pull-up resistor here on the chip select, and the other lines are floating. Now these pins, RG9, RG8, RG6, RG7, these go to specific pins on the processor. And R stands for register, G is the port, register G, and these are the bits 9, 8, 6, and 7. So up here in the text, it tells you RG9 is pin 27 on our board, RG8 is pin 26, RG6 is pin 24, and RG7 is pin 25. Now, because these are all hooked up, the SDI, SCK, SDO, you don't have to do anything with these. But the one thing you need to be aware of is, what is our chip select? Our chip select is pin 2, and our chip select is RG9, which is pin 27. And the reason that's important is in the labs, it's going to tell you to start to change the chip select, whatever the default chip select is in your lab. So it says it's set to 8, and it says change it to whatever we're using. What we're using is pin 27. Okay, here's a table that's just showing different pin outs. This is not super critical. We don't need to worry about that because our board's already wired up. Gary also noticed there's a lot of places in this lab where it says 115.00. It should say 115.200 for the baud rate. The first 4 parts, what you're doing is you're just opening the sample labs. Open the card info example file, examples SD card info. File, card info. So here's the library. And in here it says there's 2 places where you need to change the chip select. And it shows pin 8 and pin 10. The thing about it though is I went through and I changed them all. So you don't have to do that. There's only one place. So up here where it says chip select default, you just need to change this to 27. So once you've changed that, oh, and then you got to change the baud rate to 115, 200. So once you've changed those 2 things, then you could run this example. And what the card info example will do is it'll tell you things like your SD card is there, found a file system. How big is the file system in bytes, kilobytes, or megabytes? And I think when you put a gigabyte card in there, it actually flips out and doesn't display the gigabytes properly. And that's it. And it just runs once. Oh, one thing I noticed here, there's no loop, right? This all runs in the setup. So because it's in the setup and we're using SD, you should also put a delay in here. say to do that?
The line delay at the end.
Well, you need a delay before you start printing stuff out. So you upload, and then delay, and then open your serial terminal, and then all this stuff will print out. So this first one, it just does card info. You get your card info stuff. Part 2, well, it talks about you can do some different things and change what you see. Part 2 is the files example. So open examples, SD files. This one, do the same thing again, right? You're going to change this to 27, just to 115, and you should have a delay in here. It says it's initializing the card, and if we look at what this does, so this one just sets up our pin modes, it does digital writes. Pointing out it's redundant because these two, chip select SD default and chip select, they're the same. And then what we'll do is it'll say SD begin, which initializes your SD card, and if it doesn't work, it'll print out initialization failed, and if it does work, it'll tell you initialization done. And then it checks to see, it says SD.exists. And so what SD.exists does is it says, does the file example.txt exist on your drive? If it does, it'll tell you, hey, it exists. Otherwise, it says it doesn't exist. And then it says it's going to create a new file. Creates a file called example.txt. It says this is what's called a file handle. So it'll say sd.open example.txt, and we're going to open it for writing. So we're going to write data to it, and it returns my file, which is a variable that stores information about the file we just opened. And then we say myfile.close. So this creates this example.txt file. And then it goes through and checks to see if it exists again. It doesn't actually write anything to the file, it just creates it. Checks to see if it exists again, and it should now print out that it does exist. And then it does this command sd.remove, and it actually removes example.txt, so it will delete the file. So this example checks for the existence of files, it creates a file, checks for the existence again, and then deletes the file that was just created. And that's all that this example does. And it does it all in the setup. So that's part 2. So basically you just try these programs, verify that they work. There might be some things, change the name of some files. So there's some things it tells you to do. And then the next one is the read-write example. So we'll open examples, SD, read-write. So the read-write, you do the same thing again. You got to change this to pin 27. Change this to 115, 200. Put this delay in. This one initializes the digital I/O, initializes the card with sd.begin. If it's successful, or if it's not successful, it prints out that it failed and it ends. Otherwise, it says it initialized. Then it opens a new file called test.txt. So my file is a file. It's a variable that keeps track of the file that we open. Okay. So the sd.begin, if it returns 0, it will have failed. Otherwise, it will say initialization done. So the next line here says my file equals sd.open test.txt file write. So this creates a file for writing, and the file handle. So my file is called a file handle. That it's a way we can reference that file that we just opened. And then we say if my file. So basically, if we successfully open this file, it'll go and it'll run this code, and it prints out. It'll print out to our terminal, writing to test.txt. So serial.print writes to our serial terminal. myfile.println. So this is just like writing to our serial terminal, right? But when we say myfile.println, instead of writing to the serial terminal, it writes to the file that we're creating, test.text. It writes out testing 1, 2, 3, closes the file, prints out to our serial terminal done. Otherwise, if the file wasn't opened successfully, it says there's an error opening it. Then the next part, it reopens that file that was closed. It reopens it, and then it prints out test.txt : so it's going to print out what's on that card, and then it says, while myfile.available, and then it's going to read bytes. It reads bytes out of that file, and it will print it out on the terminal. And then it closes the file. And that's the whole program. The first time you run this, when you do test.txt, it will have one line that says testing 1, 2, 3. And every time you run it, if you hit reset, every time you hit reset, it's going to open that same file again and append more lines. So every time you run it, it's going to add another line, testing 1, 2, 3, to your file. And then I think there's some stuff in the lab where it says, take this to a PC and verify, look at the file on the PC. All right? And it has some, basically what I just said is it's all written up here, or at least part of it is. The data logger example. And what the data logger does, same thing with the data logger. We're going to have to change this to 27, change this to 115, 200, add the delay. It just gives us time to open the terminal. Prints out initializing, sets up our digital I/O, initializes the SD card. Okay, now this one has a loop. And what the loop does is there's a variable called analog pin. It goes from 0 to 3, and then it reads the analog pin, stores it in a variable called sensor, adds that to a string, and then writes that string out 0 through 3. It reads pin 0 through 3, appends it with a comma. So it reads analog 0, appends it to data string. So plus equals here takes the value that got read, the numerical value 0 through 123, right? Converts it to a string and adds it to this variable called data string. And then data string adds on a comma, and it does it for channels 0, 1, 2, and 3. Then it opens this file called datalog.txt for writing. And if it opened it successfully, it writes it out, closes the file, and then prints out what it wrote. This is in a loop now. So it's going to do this as fast as possible. So it's going to create a file where it's logging your values from your A to D ports. If you hook up a pot to channel 0 and you run this program and then you spin the pot back and forth, when you stop the program and you take that program to a PC or take the SD card to a PC, you can see that the values will be changing. So it will have been recording the values from your potentiometer. Okay, so parts 5, 6, and 7, what they want you to do is take what you learned in parts 1 through 4 and add it into your program that's got the command parser. So part 5 says modify your command parser so that every time somebody types in a command, it opens a file called commands.txt, and whatever they typed in, it writes it to that file. So as you're entering commands into your serial terminal, it's going to be logging them to a file. Then there will be a command called log, which opens that file and prints everything that you logged out to your serial terminal. And then there's a command called delete, which will delete commands.txt. So this is actually like, to do this, like this is like 3 lines of code, or 4 lines of code to add this into your program. This one is maybe another 3 lines of code or 4 lines of code, and then the same thing, another 4 lines of code. So this whole thing here it's very simple, but the challenge may be in understanding how you actually write to a file and how to put it into the, and I'll help you with specific issues as they come up. And that's all of this lab.